Okay, so this is a very unique experiment, and in here we're going to learn about combustion engine, and what you will see in the lab will be the workings and the control of a Northstar 2003 GM V8 engine. The way that it is working here is that we have it on a stand, and the engine, as you know, goes through different processes that we'll explain in the lecture, but it is connected to three main systems, and those systems will be explained to you by Miguel Lozano, who's going to be here. The first system is the fuel injection system and the fuel control cycle itself. And then the second one is that the heat that is generated from the combustion inside the internal combustion engine is part of it goes in the exhaust. The other part is dissipated in the dynamometer. So we have a dynamometer that kind of simulates the loading condition on an actual running system. So Miguel is going to explain to you the dynamometer, and then the energy from the dynamometer is going to be dissipated in a water system that goes through a heat exchanger. So we have another heat exchanger to take care of the amount of heat that is generated in that particular engine. And finally, one of the important contributions that you will learn from this class is how to assess the combustion process and the influence of the air-to-fuel ratio on the level of hydrocarbons generated and the level of NOx and the water composition that comes out of that. And for that we have a catalytic converter, and the catalytic converter is instrumented. And as before before Miguel goes through all of these systems, the engine is in this lab, as you'll see, but all of the instrumentation are outside. And we have electronic control unit and ability to control the RPM and the speed of the engine and ability to control the air-to-fuel ratio. So all of that will be taken care from the control unit, from the control units outside of the lab. So for now, I think Miguel is going to go systematically through these three different components of the engine system, and then we'll move on to the control area to show you how you're going to actually implement the various steps in the laboratory. We'll cut.
Yeah, my name is Miguel Lozano. Like Professor Ghonie explained, this is the Northstar 2003 Northstar Engine fuel tank. And here's a fuel system that we've developed for this engine. It's got a loop. It's got a loop that goes from here to the engine and back. And you got the output coming out of the gas tank to the high pressure valve, high pressure pump, goes into the reservoir. Then from here, it comes out, goes through the pressure regulator, and then you got a low pressure pump here. From here, you have another regulator, and then you got the fuel flow turbine flow meter. Then from here, it goes out to the actual engine, and then you have the loop. Comes out through here. It goes to the fuel injectors, and then then from there you measure how much fuel you're actually using. Whatever comes back, then you subtract it, and you get your measurement. And you can see the loop, one in and one out. Here's a gas tank. It's a 20-gallon gas tank. It's pretty simple, like a car. Next is your load absorber. The load absorber is a superflow load absorber, and basically it applies artificial load to the engine. What it does, it has an impeller, two impellers. One impeller that's hooked up to the engine's RPM, so it's spinning at the revolutions, 5,000, 4,000 RPMs, and you have another impeller that's hooked up. It doesn't move. It's just stationary there. So when you start applying fluid pressure to the one that's not spinning, that one wants to rotate. Or when you change the angle to that one, that's hooked up to a strain gauge, and that thing converts it to horsepower and torque. That's how you get your measurement. And basically, it's like a water pump. Water comes in through here, and it comes out through here. And when you start closing this valve, that's how you start applying the fluid pressure. Okay, next is your heat exchanger. Here is our water supply. Water goes in from here. Okay, water in, water out. The water goes through all the crevices of the engine. That's how you cool it off. Here is your water turbine flow meter, your M.H2O right here, and that's going to be over there. You're going to have your meter on the other side. But basically, it's a heat exchanger. This is the actual heat exchanger. This is like a thermostat. When the temperature of the water gets to a certain temperature, this one closes and it opens up and it goes to the actual heat exchanger. When it cools down, you close this side and you open up this and you start again the cycle. That's about it as far as the heat exchanger. Now we're going to go to the catalytic converter. This is the catalytic converter. We have just your standard catalytic converter. It's not nothing different. We have a before, pre, and post cat. Pre-cat, you're going to measure before the catalytic converter. Post-cat after the catalytic converter. All that's going to be measured on the other side with the Hariba instrument. Right here is your lambda meter to measure your air-to-fuel ratio. This one's your O2 sensor that's hooked up to the actual engine. We have misters to cool off the exhaust. We also have thermocouples. But the most important thing is the catalytic converter to measure your fuel emissions exhaust. That's it.
Okay. So now we're going to move on to the engine control room. And as you can see, the control room, we have a few things in here. As you can see here, we have an engine, and the engine, when you come to the lab, you'll be able to look at the internal structure of the engine, the chains and the valves and so forth, and you'll be able to kind of correlate that with the actual diagrams that you have in the lab. And this control room it has mainly a control console, and the console that you'll see here gives us ability to not only that we can control, as you'll see, the speed or the RPM of the engine, and we can also control the air-to-fuel ratio. So these are the two main variables that you'll have in your experiment, and then you will be able to have diagnostics. And the diagnostics that come out, you will have temperature measurements, you'll have power and torque measurement, you can have RPM measurement and the airflow measurements. We also have the ability to check on the fuel, so we have a fuel gauge right here that you can check on the fuel cycle. And in addition to that, these are like analog information that I mentioned. We have digital information that you will see the speed, the torque, the air-to-fuel ratio, and the engine power are also attached to the system. So that's kind of the controls. And then this side that you will see is to analyze the performance of the catalytic converter and how we control the emissions. So we have a Horiba system, and the Horiba gives you information on the parts per million, CO, hydrocarbon, CO2, and oxygen. You also have, in addition to this, you have a sampling unit that can give you analysis for the NOx itself. So between these, you'll be able to determine the composition pre and post the catalytic converter. To control the sample that you get, we have the system you can draw a sample of exhaust before or after the catalytic converter, and you have also ability to purge that. And the information can be printed here. So what we will do is Miguel is going to show you how the engine runs, and we'll do a small variation. We'll just do one step of an RPM and an air-to-fuel ratio, and show you how the different controls that you will have, like only one step out of the many steps that you have in the laboratory. Okay.
Yeah, now we're going to talk about how to actually run the experiment. I'm going to do step by step. We're going to start off with 20% throttle. Okay, so first, this is your throttle, your gas pedal, whatever you want to call it, your throttle. And if you can zoom in, right here is going to show us the throttle position. So I'm going to get it to 20% and then stop. Okay. Okay, so there we have it at 20%. The engine, as you can hear, the engine is running. Our temperature, this is our temperature meter. We have it set at 174, it's 169, that's good. Now I'm gonna load it up. Okay. So it's loaded. Okay. Now we have it at 20%. Here you have this is all going to be printed out. The computer's going to print everything out. You have your speed, air-to-fuel ratio, engine torque, engine power. And then if we come to this different screen, number 4, you have your temperatures for your different banks. Your exhaust 1, 2, and 3, and 4. Okay, you can always go back. Now, if you're ready to take the first data set, right now we're purging the Horiba. The Horiba is being purged right now. You can hear it. It's being purged. Clean air is going to this machine and that machine. That's a Horiba. That's your NOx. Okay. Whenever we're ready to sample, we would open this and close that. This is for the pre-cat. This is for the post-cat. Before the catalytic converter, after the catalytic converter. This is your lambda meter. You would take the number to the right. Right now, it's air-to-fuel ratio is 14.7. That's what you want. 14.7, the one on the right. This one is your M.H2O meter, your turbine flow meter for the water flow rate. It's in hertz. Over here is your NOx in parts per million. You would write down the number 17. This 2000, that just means that's the maximum range this machine can handle. Anytime you see the word over, you write the word over on your data sheet. It means it went over the maximum range, which is 2000. Okay, so if we were ready to take the sample, you would open this, close this, open that. Now you're ready to start sampling. If you could zoom in right here, question marks are okay. Arrows, you wait till they disappear. That means the machine's not stable yet. So you can start taking the data. Now that you see that the arrows are disappeared, you can start taking the data. So you can start here, take these two, and then, oh, I forgot. This one, you have your fuel turbine flow meter. It's in gallons per minute. You would write that number too. So you could start with this, that, and that. And then you go to the next point, and you do the same thing again. You apply the load, you reduce the load, and then it increases the RPMs, and you start all over again. And